So today I want to make a quick video on my experience with putting together this 3D printer kit by a company called Prusa. Now, Prusa, this printer was invented by Josef Prusa from Czechoslovakia. This is a Czech Republic printer. It actually came from, I ordered it from, and it came from the Czech Republic, which is kind of interesting. You can see, it's a little beat up. I think it really had a hard time getting here, but it arrived safely, and I spent the Christmas holidays putting this together. Now, when I opened up the box, I wasn't actually sure exactly what I was going to have to do to put this together. I'd watched a couple of videos. It looked very doable. And so when I opened up the box, of course, it was filled with a whole bunch of other boxes. And inside each box was, a bunch of bags with screws and nuts and 3D printed parts, motors and gears, etc. And I had to assemble this myself. Okay, so it came with an instruction manual, and there are also some videos I found online that were very helpful. And so I followed the instructions explicitly as best I could to my understanding, and so this is what I'm going to show you. So the first thing I had to do was put the frame together. This is the frame of the printer, and it had just a few parts that you had to screw together. So there's the back part, and there's the front part. Actually, this is the back part, and that's the front part. And this was just the very first step. Then I had to put on this part here, which is where the heating bed sits on top of, and this is also the y-axis of the 3D printer. So this is it will move back and forth this way in this direction. This is the y-axis. Where am I? Okay, so there it is. So you see there's the frame, and there's the bed for the heating bed, and the y-axis. And this part right here, this is the x-axis, and these are the linear bearings that sit on these two rods and roll back and forth. And this is where the extruder will be attached to this part here. So then I had to put install the x-axis onto the frame, and this is what it looks like. So then next was really the hard part, was I had to put together the extruder. Okay, so this was a complicated part. I didn't record the steps in putting this together, but here is a video of what it looks like. Let me just see, I have to click here. Okay, so I had to assemble this part right here, and you can see there's lots of wires. There's wires for the fan, there's wires for the motor, there's wires for the extruder, etc., etc. So this was the most complicated part in putting together this 3D printer. So then I had to attach the extruder to the x-axis here. Here's the x-axis motor right here. This is the belt that drives the x-axis and allows the extruder to move back and forth in this direction. After that, I had to install the z-axis, which attaches to these two motors on either side here. You've got two rods with bearings that allow this to move up and down, and you have two worm gears attached to the z-axis motors that drive the motion up and down. So, and then I installed the LCD display. So a whole bunch of stuff happened between the last picture and this picture, but as you can see, the printer is coming together quite nicely. So after that, I had to install this part here, which is the heating bed. So this bed gets heated up to around 60 degrees when you're doing a 3D print. and this allows the 3D print to adhere to the bed and not go flying off as the 3D print is being developed. At this point, I'm pretty happy with myself. Everything went quite smoothly from beginning to up to this point. And so the next step was to attach the power supply. Now, this is where things went terribly wrong. Okay, when I went to attach the power supply, there were a couple of holes on the frame that were supposed to be a couple of holes on the frame to attach the power supply to the frame, and they just weren't there. And that is when I realized that that I did the very first step wrong. Okay, so this was a huge awakening. This was me, making a terrible mistake right at the beginning because I put this part on backwards. This was supposed to be over here, and this was supposed to be over here. And so, silly little me made a mistake, and I had to disassemble this whole unit, everything. I had to take everything apart. Not everything. I didn't have to redo the assembly, but I pretty much had to take this off, I had to take this off, and I had to reverse the motors because I put the frame on backwards. I put these two motors in reverse, and which would make it difficult for me to wire them up. So I didn't record that procedure of me making a mistake and taking this whole thing apart, but you can imagine that it was a big PIA. So and I really I wanted to scream at myself for making such a stupid mistake right at the beginning. Silly Lori. Anyways, I did it. I took it apart. I put it back together, and then I was able to attach the power supply to the frame, and more importantly, I was able to attach the microprocessor actually goes on the other side. So let me go back to here. So the power supply, so this needed to be flipped over here, and this needed to be flipped over here, so that the power supply could be attached to these holes, and the microcontroller actually requires all these holes to attach it to the frame. And so it was very important to get the step right, and I didn't. So I had to reverse it, and it was fine because I actually learned a lot in taking it apart and putting it together. I'm no longer afraid if I need to make a repair on this device, that I am not afraid to take it apart and put it back together again. I can totally do this myself. And so that was a learning experience, and I don't actually regret that happening, in the sense that I now feel comfortable that I could take this apart and make some repairs and put it back together again. So that's kind of cool. Okay, so now I've got the power supply attached to the frame. The next step was to do all the wiring, and so there was quite a bit of cable management going on. This is from the power supply. The wires need to go, and the controller is over here. And the LCD screen is to the right over here, and so all of the LCD wires needed to be managed through here, and also the wires from over here. So all of the wires needed to be nicely managed. Otherwise, it'd be a big mess. And so I think I did a pretty good job here of cable management. And then I had to wire up the microcontroller. So this is the microcontroller. All the wires had to come through here. There's a bit of cable management that I had to do right here. This is from the extruder. So the extruder needed to be wired up, the LCD needed to be wired up, and all the motors needed to be plugged into the microcontroller. So this was a little bit more of a mess. I didn't do any good cable management in here. Basically, I plugged everything in. I wanted to make sure I could see all the plugs, so I plugged everything in very carefully, following the manual, and then I'm able to kind of carefully push all these wires into here, and there's a door right here that shuts so I can hide all the cables. You don't need to see my mess in here. So at some point I may try to do some cable management in here, but really at this point, after taking the device apart and putting it back together again, I became a little impatient. I wanted to see this printer running, and so this is what impatience looks like. But it works, so I'm quite pleased with the job that I did, even though I didn't do proper cable management in this area right here. So now this is the 3D printer all assembled with the messy stuff kind of back here with the door shut and you can't see the mess. Everything looks pretty good, and I was able to start doing some prints. Now before doing the prints, I had to go through a whole bunch of calibration procedures. I had to run it through. There was some tests that I had to run through, and I had to get through each step in order to get to the next step. And so I did have some issues during the calibration, but I was able to get everything up and running after going through each step and fixing whatever problems occurred at each step. And then I was ready to do a 3D print. So this was the first 3D print that I did in the Prusa software. It actually comes with some predefined prints on an SD card. And so there was one called a whistle, and I wanted to make a whistle. And so I thought that would be simple enough. And so this was my very first print of a whistle. And of course, it didn't work very well. It didn't work well at all. It started printing the whistle, and then what happened was the whistle came loose from the bed because my Z-axis was not calibrated right. And so there's a fine-tuning in the controller. There's some fine-tuning for the Z-axis to bring it closer to the bed, and I had to run a whole bunch of tests to get it calibrated correctly. So this was way too far away from the bed, and then I changed the calibration and got a little better, but I got a little further in the print, but it still came off and created a mess. And then I went a little bit closer, and it was better, but not perfect. It still wasn't working very well. And then I finally I went a little closer, and the top looked good, but there was still something wrong with the bottom. And I think that was probably because I didn't clean the bed properly. You're supposed to clean the bed with alcohol every time before you do a print. And so let's just have a look here. I have a video of, so finally I did a good print of a whistle, and I did a time lapse of it, and there it is right here. So that I was finally able to print 2 whistles in a row where the front looked good and the back looked good. But more importantly, as you can hear, the whistle works. So then I found another model on the SD card called Marvin, and so I decided to print that. And here is a time lapse of that model being printed. So it looks like, so I was actually kind of happy to see this model. I didn't know what it was going to be, but it looks like it is Marvin the Martian. And Marvin the Martian is actually one of my quote-unquote mascots. I love Marvin, and I've got, Marvin the Martian paraphernalia. I've got a Marvin the Martian mouse pad. I've got a Marvin the Martian cover for my driver in my golf clubs, and so this print turned out very nicely. I was happy to see it turn out so well, and I felt like I was ready to do some of my own designs. So here is a scattering of the prints that I have done so far. These are not all my own designs. I started out though by doing a 3D print of a Mendelbrot fractal because of course I had to do that. So here is a 3D print of a design I did using my Mendelbrot generating software. And this is, I put it on a very slow time lapse, so it's going to take a few seconds for this to finish. But it is a really nice, nice size Mendelbrot, kind of a wall hanging or pendant, or so there it is right there. It's a fairly big size. Basically, it was a, here it is right here. It is a bump map in that each iteration I turned into a different level, and as you get closer to the edge, it creates sort of a mountain like shape. And so this turned out very well in my opinion. I was really happy with how this turned out. This was first one that I did. It didn't turn out very well, and then I recalibrated and got a nice smoother uh, pattern on these different levels. And so this I was really happy with how this turned out. So the next thing I did was I designed a holder, a magnet, a bunch of magnet holders that I can use for my ferrocell experiments. And so I want to be able to try different patterns and test the Ferrograde simulation software against the actual the physical situation. And so this is the next print that I did, time lapse of the magnet holder with a bunch of holes in it. So there it is right there. So that's this right here. Okay. Then I decided to print a primer bowl. The primer bowl, as you know, there's a couple of videos out there called the Primer Fields, and David Lapointe from the designed this magnet holder. Basically, it is a bowl where you place a bunch of magnets in these little holes in the bowl, and so I thought I would try to 3D print that. So here's the time lapse of a primer bowl being printed. Okay, and now it's done. So there was a few glitches in this bowl. There's a little piece of material stuck to it on the outside here, but otherwise it did a very nice smooth bowl. I was quite happy with it. And here it is. Now the inside isn't as nice as I would like it to be, but and this region here didn't print very well. But the magnets that I got, that I designed, that this was designed for, fits quite nicely. These magnets fit quite nicely into these holes, so I should be able to populate all these holes with magnets and complete the primer bowl. Okay, here is the underside of it, and it is actually quite good. I thought it did a pretty good job of creating a nice smooth surface for the underside of the bowl. So then I went on the internet looking for more complicated prints so that I could test out my calibration of my 3D printer. And I found this 3D model. I found a video of someone showing a bunch of 3D models, and they showed this 3D model of something called Chainmail. Okay, Chainmail is, if you don't know, because I didn't actually know, there it is being printed right here. Chainmail is the material they use when they're building armor. So it's kind of the clothing of the armor. And so here is the final print of the chainmail, and I was very, very impressed with how nicely this turned out. So there it is, front and back, and it is a linked model. It is, you can see that it's got sort of interconnections, and it's got this sort of a loose material feel to it, and this has turned out really cool. I thought this was a really cool, and this was a great test of the printer. I'm now very happy with how this printer is working and with the calibration that I did, and so I'm able to print pretty much anything I want with this printer. And so the resolution is good, the quality is good, and the material I'm using is called PLA. It has a melting point of around 215 degrees, and so this is what I'm using for all of my models at this point. And last but not least, I created a couple of 3D models using the Ferrograde software, which simulates the behavior of the ferrocell. And so here on the right, you can see the famous hypertrochoid pattern, and on the left, you can see the dipole view of the magnet under the ferrocell, and I created 3D models of this. So, but I want to be clear that these are not this is not the magnetic field of the magnet. This is what it looks like, what a magnet looks like under a ferrocell, because of the reflections off of the nanoparticles in the very thin layer between the two pieces of glass in the ferro lens. And so basically this is just a slice out of a two-dimensional slice, basically out of a three-dimensional magnetic field, and I was able to generate a 3D model of both the polar view and the dipole view. And this material, which just arrived a couple of days ago, I ordered this material because um, it glows in the dark. So I made two models of the using the Ferrograde software that AB Science developed to simulate the behaviors of the ferrocell, and I created a couple of glow-in-the-dark models of these two views of magnet. And so, so this is really fun. I could use the Ferrograde software to generate 3D models. More 3D. These are really 2D models. For all intents and purposes, these are just flat 2D models. But I could easily generate now a physical 3D model by slicing through the magnet at various levels, like I showed in a previous video, and create a 3D model. But just to be clear, that 3D model would not represent physical reality whatsoever, but I still think it would make a cool 3D model. And so that is about it. This is my experience with building a 3D printer, not from scratch, but from a very complicated kit that I had to put together myself, and I'm quite pleased actually with the results. I think this is a really great printer. It gets really great reviews. My brother Mike recommended it to me, and I could have easily ordered a pre-assembled kit, but he recommended that I put it together myself so that I understand basically how it goes together, and if something goes wrong, I'm in a better position to repair it and fix things when they go wrong. And things do go wrong with these printers, and so it's not a plug and play technology. You really do have to maintain it. You have to, sometimes things go wrong and you have to figure it out. Sometimes you have to, take it apart and fix it and put it back together again, and at least that's how it seems in the field. And so I'm quite happy that I went through this process, and I'm really happy with the results of this printer. And now the sky's the limit. I've got a million ideas, and I don't even know where to start because I have so many ideas of things I can do. So so that's about it. The other point I want to make is, if you're out there and you want to attempt to do such a thing, don't be afraid. It's not that bad. It's not easy this was not easy, at least it was not easy for me, It took many days to get through all of this and to put it together, but in the end, everything is working. And again, I'm not afraid to take this apart if I need to replace a bearing or make some other repair that needs to be done. And so this is a really great printer. I highly recommend it, even if you want to buy it pre-assembled. It is a very nice beginner 3D printer.